Look up tonight and imagine something impossible. Picture the darkness above you stripped of its most familiar companion. No silver disk casting gentle shadows across your world. No pale light dancing on water. No beacon that has guided humanity since our very first breath. Tonight, we ask you to envision a sky that has never known the moon. In this alternate reality, the blackness stretches endlessly, broken only by the distant sparkle of stars that seem suddenly smaller, lonelier. The night feels different here, heavier somehow, as if something essential has been carved away from the very fabric of existence. Children in this world would never point excitedly at the moon's face. Poets would never pen verses about lunar beauty. Lovers would never steal kisses beneath its romantic glow. But this isn't just about missing a pretty sight in the sky. The absence we're imagining tonight runs deeper than poetry, deeper than romance, deeper than the human heart itself. It reaches into the very core of what makes our planet livable, what makes life itself possible. In this moonless reality, Earth would be a fundamentally different world, one where you and I might never have existed at all. The silence of space would feel more profound without our celestial partner. Tides would whisper instead of roar. Seasons would spiral into chaos. The delicate dance of life itself would stumble and fall. As we drift deeper into this exploration, one question echoes through the cosmic void. What kind of Earth would we inhabit if the moon had never graced our sky? The answer, as we'll discover, is more startling than you might imagine. To understand what we've lost, we must travel backward through deep time, past the rise of humanity, past the dinosaurs, past the very emergence of life itself. We journey to an era when our solar system was young and violent, a cosmic shooting gallery where planets were still finding their places in the celestial dance. 4.5 billion years ago, Earth was not the serene blue marble we know today. It was a hellish world of molten rock and toxic atmospheres, barely recognizable as our future home. The young sun blazed with unstable fury, and space itself seethed with debris. Asteroids the size of mountains, planetesimals seeking their destiny, and wandering worlds on collision courses with fate. On one particular day, when day and night meant nothing on this alien Earth, something extraordinary happened. A Mars-sized body, which scientists now call Theia, came hurtling through space toward our planet. Picture the scene. Two worlds, each following the gravitational choreography written in the laws of physics, moving inexorably toward a cosmic collision that would reshape everything. The impact was beyond imagination. When Theia struck Earth, the force released energy equivalent to billions of nuclear weapons detonating simultaneously. The collision was so violent that it nearly shattered our planet entirely. Molten rock sprayed into space like cosmic tears, carrying with it pieces of both Earth and the mysterious impactor. For hours, our world was wrapped in a glowing shroud of vaporized stone and metal, but from this destruction came creation. The debris from this cataclysmic collision began to coalesce in Earth's orbit. Gravity pulled the scattered fragments together, slowly, patiently sculpting them into a sphere. What emerged was our moon, not just a random rock captured by Earth's gravity, but literally a piece of our own world. Born from violence and forged in the cosmic fire, this violent birth explains why the moon is so uniquely suited to Earth. It's not a coincidence that it stabilizes our planet so perfectly. It was created from the very materials that make up our world. The collision didn't just give us a companion in the sky. It fundamentally shaped the conditions that would eventually allow life to flourish. But here's the haunting question that will guide us through the rest of our journey. What if that cosmic collision had never occurred? What if Theia had missed Earth by just a few thousand miles, sailing past into the cold depths of space? Tonight, we explore the Earth that might have been. In our reality, Earth tilts at a gentle 23.5 degrees as it orbits the sun, giving us the steady rhythm of seasons that life has depended upon for billions of years. This tilt is like a cosmic gyroscope, remarkably stable thanks to the moon's gravitational embrace. But in our moonless world, this stability vanishes, and Earth becomes a planet at the mercy of chaos. Without its lunar anchor, Earth's axial tilt would wander dramatically over millions of years, swinging anywhere from nearly upright to lying almost on its side. Imagine the consequences. periods where one hemisphere bakes in endless summer while the other freezes in perpetual winter, followed by sudden shifts that would send the planet reeling into entirely new climate patterns that we don't have to imagine this scenario entirely. We can look to Mars for a glimpse of this chaotic future. The red planet, lacking a large stabilizing moon, experiences exactly this kind of axial wandering. Over the course of millions of years, Mars tilts wildly, creating climate swings so extreme they make Earth's ice ages look gentle by comparison. Sometimes Mars tilts so far that its polar ice caps completely evaporate, sending the planet into a global greenhouse state. Other times, it straightens up so much that ice advances nearly to its equator on our moonless Earth. These same wild swings would occur, but with even more dramatic consequences due to our planet's larger size and more complex atmosphere. Picture ice sheets advancing and retreating across entire continents in geological eye blinks. Imagine tropical forests suddenly plunged into decades of winter, then scorched by summers that never end. The Amazon rainforest might find itself covered in glaciers, while Antarctica could bloom with temperate life. Life, remarkably adaptable as it is, might still find a way to survive these cosmic mood swings. But the complex, interconnected ecosystems we know today would be impossible. Migration patterns would become meaningless when winter might last for centuries. Seasonal behaviors would provide no evolutionary advantage in a world where seasons themselves lose all meaning. Perhaps most intriguingly, in such a chaotic world, could human civilization ever have emerged? Our agriculture, our calendars, our very understanding of time itself is built on the reliable cycle of seasons. Would our ancestors have ever developed farming if they couldn't predict when to plant or harvest? Could humanity even adapt to a world where the only constant is change itself? Stand on any shoreline today, and you witness one of the moon's most visible gifts to Earth, the eternal rhythm of tides. Twice daily, the ocean rises and falls in response to our lunar companion's gravitational pull, creating a dynamic zone where sea meets land, a zone that may have been evolution's most important classroom in our moonless reality. These tides would shrink to mere whispers of their current magnitude. The sun would still exert its gravitational influence, but without the moon's much stronger pull, tidal ranges would be reduced to perhaps a tenth of what we experience today, where we now see dramatic tidal zones stretching for miles. We would find only narrow strips of barely fluctuating water. This transformation would rewrite the entire story of life on Earth. Today's tidal zones are among the most biologically active places on our planet, natural laboratories, where marine life first learned to survive out of water. Here, in the rhythm between wet and dry, organisms developed the ability to breathe air, to withstand desiccation, to move across solid ground. These harsh but regular conditions provided the perfect evolutionary pressure cooker for the transition from sea to land. Remove the tides, and this crucial stepping stone disappears. The first amphibians might never have emerged from primordial seas. The invasion of land by life itself might have been delayed by hundreds of millions of years, if it happened at all. Instead of the rich terrestrial ecosystems we know today, Earth might have remained a largely aquatic world, with life confined primarily to the oceans. Consider the delicate creatures that call today's tidal zones home: the hermit crabs scuttling between pools, the anemones clinging to rocks as waves crash around them, the countless species of fish that use shallow tidal areas as nurseries for their young. In a moonless world, these ecological niches would simply not exist. The gentle lapping of minimal tides would create no such dynamic environments. The implications extend far beyond marine life. Rivers would flow differently without strong tidal influences, potentially altering the formation of deltas and coastal wetlands. Ocean circulation patterns, driven partly by tidal mixing, would be fundamentally changed. Even the chemistry of seawater might be different, as tidal action plays a crucial role in cycling nutrients between deep and shallow waters. Perhaps most sobering of all, humans themselves might never have existed in this altered timeline. Our evolutionary lineage traces back through countless ancestors who lived in and around water, from the first fish to venture onto tidal mudflats to the early mammals who hunted along prehistoric shores. Without the moon's tidal gift, Would evolution have followed the same path that eventually led to us? Would we even exist to contemplate our own absence? The moon has been life's metronome for billions of years, conducting a symphony of natural rhythms that pulse through every living thing on Earth. From the spawning cycles of coral reefs to the migration patterns of Arctic terns, countless species have synchronized their most crucial life events to the lunar calendar. But in our moonless world, this cosmic conductor falls silent, leaving life to find new ways to keep time. Consider the coral reefs of our reality, where entire ecosystems coordinate their reproduction to lunar phases. On certain nights, triggered by the moon's cycle, billions of coral polyps release their eggs and sperm simultaneously, creating underwater blizzards of new life. This precisely timed event ensures maximum fertilization success and has been happening for millions of years. Without lunar cues, this remarkable synchronization would never have evolved, leaving coral reproduction far less efficient and reef ecosystems fundamentally different. Sea turtles, those ancient mariners of the ocean, have navigated by moonlight for over 100 million years. Female turtles return to their birth beaches during specific lunar phases, using the moon's position to time their nesting and help their hatchlings find the ocean. In our moonless reality, these magnificent creatures would need entirely different navigation systems. If they could navigate long distances at all, the absence of lunar cycles would reshape human culture in profound ways. Ancient civilizations built their calendars around the moon's phases, creating the foundation for agriculture, religion, and social organization. The very concept of months comes from the moon's cycle. Without this celestial timekeeper, human societies might have developed entirely different systems for measuring time, or perhaps struggled to develop complex calendars at all. Imagine the stories we would never have told. The myths of werewolves transforming under the full moon, the romantic traditions of moonlit proposals, the countless poems inspired by lunar beauty. None of these cultural treasures would exist in our moonless world. The human imagination itself might be fundamentally different, perhaps more focused on the sun and stars, but lacking the gentle, changing presence that has inspired so much art and literature. Religious traditions across the globe have incorporated lunar cycles into their most sacred observances. From the Islamic calendar to Jewish holidays, from Hindu festivals to Buddhist celebrations, the moon has provided spiritual rhythm to human cultures worldwide. In our alternate reality, would humanity have developed the same rich spiritual traditions, or would our connection to the cosmos feel somehow diminished? Even our language would be different. Words like lunacy and moonstruck, phrases like once in a blue moon and over the moon, these would never have entered human vocabulary. The absence of lunar influence might have left human culture not just different, but somehow less colorful, less connected to the natural rhythms that have shaped consciousness itself. In our moonless world, night truly means darkness. Without the moon's gentle illumination, the hours between sunset and sunrise would be blanketed in a blackness broken only by starlight and the occasional flash of lightning. While this might make the stars appear more brilliant, the absence of moonlight would fundamentally alter the course of evolution and human development. Picture the nocturnal hunters of our reality, owls gliding silently through moon-dappled forests, their prey visible in the silvery light filtering through leaves. In our alternate world, these same forests would be pitch black, giving predators an overwhelming advantage. Night-hunting animals would dominate ecosystems in ways we can barely imagine, while prey species would be forced to become entirely diurnal or develop extraordinary new senses to survive. The evolution of human vision itself might have taken a different path. Our eyes, adapted for both day and night vision, developed their capabilities partly in response to navigating by moonlight. In a moonless world, early humans might have evolved enhanced night vision rivaling that of cats, or perhaps developed entirely different sensory systems like echolocation. The very structure of human society could have been shaped by our response to such profound darkness. Consider how this endless night would have affected human exploration and migration. In our reality, early humans used moonlight to travel safely at night, expanding their territories and following animal migrations across vast distances. Without this natural illumination, human expansion might have been limited to daylight hours only. potentially slowing the spread of our species across the globe by thousands of years. Fire would take on even greater importance in this moonless world. Rather than being one tool among many, fire would become humanity's primary weapon against the darkness, not just for warmth and cooking, but as an essential source of light for any nighttime activity. The development of civilization itself might have been delayed until humans mastered more sophisticated lighting technologies. Navigation at sea would present almost impossible challenges. Sailors in our reality have used the moon's position and phases for navigation for millennia. In our alternate world, ocean travel would be far more dangerous and limited, potentially preventing the great age of exploration that connected human cultures across the globe. Islands might have remained isolated for thousands of years longer, developing unique civilizations that never encountered the outside world. The psychological impact on humanity would be profound. The comfort we unconsciously derive from moonlight, the sense of gentle illumination in darkness, would be entirely absent. Would humans have developed different relationships with night and darkness? Might we have become a species that retreats entirely indoors after sunset, never developing the rich traditions of nighttime activities that characterize our culture? High above our heads, an ancient guardian stands watch. The moon, scarred by billions of years of cosmic bombardment, tells the story of countless asteroids and comets that might otherwise have found their way to Earth. Each crater on its surface represents a potential catastrophe deflected from our world, making the moon not just our companion, but our protector in our moonless reality. Earth would face the full fury of space debris alone. Computer simulations suggest that without the moon's gravitational influence and its role as a cosmic vacuum cleaner, Earth would experience perhaps 5 to 10 times more asteroid impacts than we've actually endured. The implications of this cosmic vulnerability are staggering. The asteroid that ended the age of dinosaurs 66 million years ago was just one of many large impacts Earth has suffered. But in our moonless world, such extinction-level events would occur with terrifying regularity. Every few million years, instead of every few hundred million, massive asteroids would slam into our planet, resetting evolution's clock and preventing the development of complex life forms. Imagine Earth's history rewritten by this constant bombardment. The emergence of multicellular life might be delayed by billions of years as each evolutionary advance is wiped clean by the next cosmic impact. Complex ecosystems would never have time to develop before being obliterated by rocks falling from space. The patient work of evolution, building coral reefs, growing vast forests, developing the intricate food webs we know today, would be constantly interrupted by apocalyptic collisions. The moon's protection extends beyond just absorbing impacts. Its gravitational influence also helps clear Earth's orbital path of debris, essentially sweeping space clean in our cosmic neighborhood. Without this cleaning service, Earth would orbit through a much more dangerous region of space, filled with rocks and ice chunks waiting to rain destruction on our world. Consider how this would affect the development of life itself. In our reality, mass extinctions, while traumatic, have also driven evolution forward by creating new ecological niches for surviving species to fill. But if such extinctions happen too frequently, life would never have the opportunity to recover and diversify. Earth might be locked in a perpetual cycle of destruction and basic survival, never advancing beyond simple organisms. The largest impacts would do more than just cause extinctions. They would fundamentally alter Earth's surface and atmosphere. Frequent bombardment might prevent the formation of stable continents, keep the atmosphere in constant turmoil, and make the development of stable climates impossible. In such a world, could life itself persist, much less evolve into the magnificent diversity we see today? Perhaps most chilling of all, if humanity somehow managed to evolve in this cosmic shooting gallery, we would live under the constant threat of extinction from above. Every generation would know that a rock from space could end civilization at any moment. Would such a species ever develop space exploration, knowing the dangers that lurk beyond our atmosphere? Or would we remain forever earthbound, hiding from the cosmic threats above? In our moonless world, human civilization would unfold as a fundamentally different story, one missing crucial chapters of inspiration, navigation, and cultural development that we take for granted. The absence of our celestial companion would reshape not just our practical world, but the very essence of human creativity and imagination. Consider the ancient civilizations that built their greatest monuments in alignment with celestial bodies. The pyramids of Giza, Stonehenge, the temples of Angkor Wat. Many of these architectural marvels incorporate lunar alignments alongside solar ones. In our alternate reality, these monuments might never have achieved their sublime precision, as ancient architects would lack the moon's reliable cycles to guide their calculations. The great explorers of human history, from Polynesian navigators crossing vast Pacific distances to Viking seafarers reaching the Americas, all relied heavily on lunar navigation. These brave souls used the moon's position and phases to determine their location and direction across trackless oceans. Without this celestial compass, the age of exploration might have been delayed by centuries, leaving civilizations isolated and humanity's expansion across the globe dramatically slowed. Mathematics and astronomy themselves would have developed differently. The Babylonians, Greeks, and Islamic scholars who laid the foundations of these sciences drew much of their inspiration from observing lunar cycles and calculating eclipse predictions. The very concept of trigonometry emerged partly from attempts to model the moon's motion. In our moonless world, mathematical progress might have followed entirely different paths, potentially slowing humanity's understanding of the universe. Language and literature would bear the scars of this absence. Countless words derive from lunar concepts. Consider month, Monday, menstruation, and hundreds of other terms rooted in lunar observation. Poetry would lack the rich metaphors of waxing and waning, of lunar beauty and romantic moonlight. Shakespeare's lovers would never meet beneath the inconstant moon, and countless other literary masterpieces would simply never have been written. Religious and spiritual traditions worldwide would be fundamentally altered. The lunar calendars that govern Islamic observances, Jewish holidays, and Buddhist festivals would never have developed. The archetypal feminine associations with lunar cycles, present in cultures from ancient Greece to modern Wicca, would be absent from human consciousness. Our spiritual connection to the cosmos would feel somehow incomplete, missing the gentle, changing presence that has inspired reverence for millennia. Art and music, too, would tell different stories. The countless paintings of moonlit landscapes, the musical compositions inspired by lunar beauty, the dances performed under the full moon, all of these would be absent from human culture. Claude Debussy's Clair de Lune would never have been composed, and Beethoven's Moonlight Sonata would remain unwritten. The human artistic imagination would be subtly but profoundly diminished. Perhaps most intriguingly, the scientific revolution itself might have unfolded differently. Galileo's observations of lunar craters and phases provided crucial evidence for the heliocentric model of the solar system. Without the moon to study through his telescope, the shift from Earth-centered to sun-centered cosmology might have taken much longer to achieve. The absence of the moon from human history would create a cascade of delays and detours in humanity's scientific journey, potentially setting back our understanding of the cosmos by centuries. Every major astronomical breakthrough, from ancient observations to modern space missions, has been intertwined with our relationship to the moon. Galileo Galilei's revolutionary telescopic observations in 1609 transformed our understanding of the universe, and the moon played a starring role in this cosmic revelation. His detailed drawings of lunar craters and mountains proved that celestial bodies were not perfect, unchanging spheres as ancient philosophy claimed, but worlds with landscapes as rough and varied as Earth's. In our moonless reality, this crucial evidence for an imperfect, dynamic cosmos would have been much harder to obtain. The development of the telescope itself might have proceeded more slowly without the moon as an obvious target for observation. Early astronomers were drawn to study our satellite because it was large, bright, and showed clear surface features even to the naked eye. Without this compelling subject, the refinement of telescopic technology might have lagged, delaying discoveries throughout the solar system. Newton's law of universal gravitation emerged partly from his attempts to explain the moon's orbit around Earth. The mathematical principles he developed to describe lunar motion became the foundation for understanding All orbital mechanics. In a moonless world, Newton might have had to rely on more distant and subtle planetary motions to develop his theories, potentially adding decades to the scientific revolution. The measurement of distances in space would have proven far more challenging without the moon. Astronomers used lunar parallax, observing the moon from different locations on Earth, to first accurately measure the distance to a celestial body. This became the baseline for calculating distances throughout the solar system. Without this nearby reference point, mapping the cosmos would have required entirely different, more complex methods. Most dramatically, human space exploration would have followed a completely different trajectory. The Apollo program wasn't just about landing on the moon. It was about learning how to leave Earth at all. Every technique needed for interplanetary travel, from orbital mechanics to life support systems, was developed and tested during lunar missions. The moon served as humanity's training ground for space exploration. In our moonless world, the first human missions beyond Earth orbit might have been directed straight to Mars or Venus, a vastly more dangerous and complex undertaking. Without the moon as a stepping stone, space agencies would have needed to develop much more sophisticated technology before attempting any crewed missions beyond Earth orbit. Human space exploration might be decades behind where it is today. The very motivation for space exploration could have been different. The moon captured human imagination in a way that sparked the space race and inspired generations of scientists and engineers. Without that visible, attainable goal hanging in our sky, would humanity have felt the same urgency to reach for the stars? The psychological drive to explore space might have remained a distant dream rather than becoming the reality that reshaped the modern world. Perhaps most profoundly, our understanding of our place in the universe would be fundamentally altered. The moon has served as our window into cosmic processes, from impact cratering to tidal forces to orbital dynamics. Without this nearby laboratory, human knowledge of astronomy and planetary science would be impoverished, leaving us less equipped to understand our cosmic environment and perhaps less motivated to explore beyond our world. As we return to the present moment and gaze upward at the familiar sight of the moon hanging in our evening sky, we carry with us the profound realization of what might have been lost. Throughout our journey into this alternate reality, we've discovered that the moon is far more than a beautiful ornament in the heavens. It is the silent architect of life as we know it. The gentle lunar presence we so often take for granted has shaped every aspect of our world's story, from the stabilization of our seasons to the rhythm of our tides. From the protection against cosmic bombardment to the inspiration for human culture and science, the moon has been Earth's faithful companion through 4.5 billion years of cosmic history. Its influence touches every corner of existence, seen and unseen, acknowledged and overlooked. In our exploration of the moonless Earth, we witnessed a world where life might have remained forever trapped in the seas, where seasons would spin chaotically through extremes that would challenge any form of complex existence, where the night sky would offer only darkness broken by distant stars. We saw a reality where human civilization, if it emerged at all, would be fundamentally impoverished, lacking the cultural richness, the navigational tools, the scientific inspiration, and the poetic beauty that lunar presence has given our world. The moon's gift extends beyond the practical into the realm of wonder itself. It has taught humanity to look up, to question, to dream of other worlds. It has provided the stepping stone that allowed us to become a spacefaring species. Without its presence, we might still be earthbound, our imaginations never having been captured by the possibility of walking on another world. Tonight, as you step outside and look up at the moon, remember that you are witnessing one of the universe's most remarkable partnerships. Earth and moon dance together in a gravitational embrace that has lasted longer than multicellular life has existed on our planet. This partnership has made possible everything from the first creatures crawling onto primordial shores to the astronauts who left human footprints in lunar dust. The moon reminds us of our cosmic fragility and our cosmic significance. We exist because of an ancient collision that could have destroyed our world, but instead gave us the perfect companion. We thrive because of gravitational forces that gently tug at our oceans and stabilize our seasons. We dream because of the silver light that has illuminated human nights since our species first learned to wonder in a universe of countless worlds. Most orbiting their stars alone, Earth's partnership with the moon represents something precious and rare. We are the beneficiaries of a cosmic accident that became a cosmic gift, a gift that shaped not just our planet's physical evolution, but the very possibility of consciousness, culture, and the capacity to contemplate our place in the cosmos. As the moon continues its eternal journey across our sky, it carries with it the story of our world's past and the promise of our future among the stars. It stands as a testament to the delicate balance of forces that make our existence possible and a reminder that we are part of something far grander than ourselves, a cosmic dance that began with violence and bloomed into the extraordinary beauty of life on Earth.